So here OSI model versus IoT. So if you go to the networking book or the fundamentals of the computer networks, we can find out one OSI model, which is very first. Now if we read the subject, we can figure out. But what similarity is there, OSI model and the IoT, whether both are the same or they have some difference in that case. So first we see the similarity. So both protocol stacks, both are the protocol stacks. That means this is the same for that. Describe how devices in the network can communicate with each other. So both protocols, they are take care about the communication of the devices in a network. So they assume that there is only one network is there and all the devices are connected either wired or wireless, and how they can communicate. So both take care of the same principle, and both help make sure that the data can be sent and received reliable and standardized way. So here we highlight that standardized way, so that if you are doing the programming, if you are doing the coding, then other can understand, other can modify and work on the standard devices, whatever the licensed devices are there. So the both they take care of these things, that standardizations, and they also support the devices with a different form each others. So if the devices are different type, they can support, say for example, one laptop can communicate with your mobile, mobile can communicate with your laptop. Similar is in IoT, if the sensors are from the different that brand or different manufacturers, they can communicate with each other. This is the responsibility of the IoT protocol stack. They can provide this functionality. So communication and standardization with the different type of the devices, these are the similarity in these two, OSI versus IoT model. But when you go to the what differences is there, so OSI model is a conceptual model. That means they have some concept sort of thing, not a that is specific for a protocol stack sort of thing. But IoT model is more specific towards the protocol stack designed for the IoT devices. So whatever the protocol suitable for the IoT devices, they put in the IoT protocol stack. Okay. They are not consider other things. So OSI model describe how data is transferred over any type of the network. They can use whatever the wireless sensor network, ad hoc network, wired, wireless, all these things covers together. But IoT models, whatever the IoT models is designed, they are specific for the IoT devices, not for the other devices. The another important difference and interesting difference is that OSI model thinks more about the how data is sent and received, while the IoT models is more specific and focus on the unique characteristics of the devices. That means the IoT model, they also worried about the data as well as the device constraint. So say for example, if you have the limited processing, you have the limited power, limited memory, wireless communication, bandwidth constraint, all these things need to worried about the IoT models. But OSI model, they take care only about the sending and receiving the data because they assume that their devices are sufficient processing, everything is perfect. But IoT, they assume that the devices, they already have their constraint in terms of the processing, in terms of the storage. So whenever they talk about the sending the data, first they need to say that whether their processing or their memory is sufficient or not. Last difference that in this direction, that OSI model provides a high degree of abstract. That means you have some abstract information each and every layer, each and every protocol and duties and responsibility. Here the IoT model is designed to be more lightweight and effective. That they provide as light as possible because this is the constant devices. They have the limitation in each and every aspect. So this is the difference between OSI model and the IoT model. So whenever we work on the IoT model, we select the devices and the protocols. We need to take care in the mind that which specific protocol that protocols we have used, and they are more specific towards the device, not only towards the data transmission and receiver. Also, lightweight and effective model is required because of the device constraint. Now, the OSI model is the 7-layer model, and the IoT model is usually that is the 5-layer models. So, what 5 layers are there? Physical layer, data link layer, sometimes it together, but we can picturize that as a different physical layer, data link layer, network transport, session, presentation and application layer. But session and presentation is also the part of this application layer. That means there is only one layer is there in IoT model. So there is no layers named as the session and presentation in IoT models. And why these layers are not required in IoT model, or why we are not highlight these layers in the IoT model? The first reason is that IoT device is designed to be lightweight. with a focus on the essential functionality need for communication. That covers only the essential functionality, whatever the essentiality is required, not the other quality of services or numbers of heavy duty services are not possible. So that's why they are not take care of about that things, and they are not given in that models. So both layers in OSI model provide. So session and presentation layer, why OSI model is required? To additional functionality in the more complex network applications such as video conference or remote desktop applications. These are very heavy applications and require a huge complexity, and such type of applications are not required in IoT. Therefore, they are not required this session and presentation layer in IoT models. And adding extra layers to the protocol stack would increase the cost of the devices. So along with the processing, storage and power consumption, IoT also worried about the cost. So if you have more layers, if you have more bulky architecture of the networking, definitely your cost is high, because the IoT device, whenever you deploy the IoT device, a large number of devices we need to deploy, and it is sometimes we are not able to retrieve the devices after the deployment in some scenarios. So in that case, definitely we can work only the low cost devices. If the device cost is high, then we are not able to deploy a large number of devices. Now we see that, okay, this is the 5-layer IoT protocol stack is there. So these 5 layers, they have their responsibilities. Each and every layer, they have their fixed responsibility, and we can divide accordingly. So physical layer is the bottom layer that responsible for physical transmission of the data. That means the raw data comes into the picture, and this is the last one layers, which is directly responsible of the transmission of the data with different medium. And apart than that one, data link layer is manage the transmission of the data across the physical link, not across the entire network. That is just above the physical layer, and they are responsible for transmission of the data with respect to the physical link. So whatever the Bluetooth, Wi-Fi, Zigbee, LoRa, we have seen that protocol stacks and other thing, that is the part of the data link layer, and then or the physical layer, that is a part of these two layers. Now comes to the network layer, which is responsible of the managing the routing of the data across the network. End to end is the responsibility is there. That means whatever the node 1 transmit to the node n, whatever the intermediate nodes or network comes into the picture, they are also worried about these things. So network layer is required because of the across the network transmission, and above than that one, transportation layer is required for reliable data delivery. Whatever the data is there, that is the some congestion comes into the picture, some that the collision is there. So all these things are the responsibility of the transportation layer, that they are responsible for reliable delivery of the data that up to the process to process. Now come to the final and the topmost layer is the application layer, which is the response for application specific data protocol used for the by the IoT devices, where the user is attached with the application layer. So if you use some Android app or some SCTP protocol and MQTT protocol, XMPP protocol, all these are the application layer topmost layers protocols. So they are worried about how the specific data can control, how handle the specific data, what protocols are required by the IoT devices. This is the application layer protocol. So these are responsibilities of these protocols with respect to the layers in the IoT models. And these are the well-known protocols that is working with the each layer, physical layer, Zigbee, Wi-Fi, Bluetooth, LoRa, RFID or Sigfox, whatever the devices. Their make protocol is the data link layer with respect to that one connected with this. Network layer, 6LoWPAN, RPF, IPv4 and IPv6 in the network layer, and transport layer is the same as whatever the simple TCP/IP model, TCP, UDP and SCTP protocol. Application layer, whatever the MQTT, CoAP, XMPP, DDS, SCTP, all these are the application layer protocols in IoT model. So I hope so that up to now in this course we already covered the physical layer and data link layer. So that's why we directly jump to the network layer and transport layer today in this talk. So this is the that means some layered and the protocol architecture of IoT protocol stack, and this figure I have taken from this source. So here we can see that the physical layer and data link layer, these two layers combinedly responsible for Wi-Fi, for RFID, NFC, Bluetooth and low energy, 3GPP, and whatever the Zigbee is there. These are the responsible for that one. Up to the that one, network layer comes into the picture. So this is the node-to-node communication. This is the network communication, entire network communication. So here 6LoWPAN comes into the picture. So you can see that very interestingly they have written that 6LoWPAN box is somewhere overlapped with IPv6 as well as overlap with the RPL and also overlap with these protocols. That means they work as a adaptation layer or intermediate or sandwich layers, and they combine all these together. So this is only the possible way that how we can use these together. So 6LoWPAN, they work on the IPv6. For the routing purpose, they use the RPL protocol, and for communication of the data and other things, they have their own protocol stack, headers, and other things, and they are also worried about these things. Above then that one, the transport layer comes into the picture, which is the either TCP or UDP at that level. Application layer is the topmost layer where the application user is there. These are your Android app and other things, applications are there, and they have their AQMT, MQTT, CoAP, SCTP protocols are there. They provide the data handling at the application layer. So this is the protocol stack, and one thing we observe here is that the Zigbee. Zigbee, they have their separate, that means partition. So here they use the Zigbee radio and they go to up to this one. That means they take care of about all these things together like this one.